For today, I'm gonna do a demo for debugging. You can go to this address. It's codingdojo.org, kata putter. I will read over the problem for you. Then I have a code that we already downloaded from the internet, made some changes to it, so it has some errors now. We go over the code, we find the bugs, and we try to fix them and have all of our test cases run. If you also want to work with me as I fix the code, there is a file called Debugging Demo. So you're welcome to download that and follow the steps that I'm taking. So I'm going to read you the problem. So first of all, what kata means here, what kata means in general. So in martial arts, kata is called like those sets of practice that you have to do over and over and over again until you master it. So technically the idea of coding kata is the same thing, that there are these practices that you are supposed to do multiple times until you master it and you know how to do it well. So I'm going to read over it for you. If you want to try this kata for yourself at your dojo meeting, read the problem description and see if the kata appeals to you. The rest is commentary and helpful clues for if you get stuck solving it. I would recommend trying the kata for yourself before reading too much of it. It means after the clue, obviously you have to read the problem description. And also this website has other katas too. This actually is a pretty good practice for you to improve your skills as a software engineer. And also once you solve the problem, you can upload it to your repository and you already have a portfolio to show your potential employers when you're doing interviews. So the problem description. Once upon a time, there was a series of 5 books about a very English hero called Harry. Well, back then there were only 5 books, they didn't have the 6th and 7th one. At least when this kata was invented, there were only 5. Since then, they have multiplied. Children all over the world thought he was fantastic, and of course, so did the publisher. So in a gesture of immense generosity of mankind and to increase sales, they set up the following pricing model to take advantage of Harry's magical powers. 1 copy of any of the 5 books costs €8. If, however, you buy 2 different books from the series, you get a 5% discount on those 2 books. If you buy 3 different books, you get a 10% discount. With 4 different books, you get a 20% discount. If you go the whole hog and buy all 5, you get a huge 25% discount. Note that if you buy, say, 4 books, of which 3 are different titles, you get a 10% discount on the 3 that form part of a set. But the 4th book still costs €8. Putter mania is sweeping the country, and parents of teenagers everywhere are queuing up with shopping baskets overflowing with putter books. Your mission is to write a piece of code to calculate the price of any conceivable shopping basket, giving as big a discount as possible. There are some examples here that you can think of. So for example, what would be the discount if you have 2 copies of the first book, or 2 copies of the second book, or the third one, or 1 copy of the 4th book, 1 copy of the 5th book. So like if you have all of these, what would be your combination? You'll find that this kata is easy at the start. You can get going with tests for baskets of 0 books, 1 books, 2 identical books, 2 different books. And it is not too difficult to work in small steps and gradually introduce complexity. So technically you can do exhaustive testing for this. There wouldn't be that many cases. But you can also get a bit smarter and try to do representative testing. Again, this is not something that you need to do right now or, ever for this course. But it's something to consider, and that would be an interesting case for you to see the difference between exhaustive testing and representative testing. Both ways you are covering all the conceivable cases, but one of them is obviously you can do it with lower number of test cases. However, the twist becomes apparent when you sit down and work out how much you think the sample basket above should cost. It isn't a 5 times 8 times 0.75 plus 3 times 8 times 0.9. It is in fact 4 times 8 times 0.8 plus 4 times 8 times 0.8. So with the second formula, you actually get more discount than the first one. So you also have to find the right combination to get the most discount for each set of books that you want to buy. So the trick with this kata is not that the acceptance test you've been giving is wrong. The trick is that you have to write some code that is intelligent enough to notice that 2 sets of 4 books is cheaper than a set of 5 and set of 3. You will have to introduce a certain amount of clever optimization algorithm, but not too much. This problem does not require a fully fledged general purpose optimizer. Try to solve just this problem well in order to share it for everyone. Trust that you can generalize and improve your solution if and when new requirements come along. So again, for this session, we are not, or even like for the purpose of this course, we're not solving the problem. We have a code that already is trying to solve it. We made some changes to the code, so there are some bugs, and we try to find those bugs and fix them. I already have this project open. I made one change here. So we have, so for example, in our test, we have shopping basket test, and we have shopping basket 2 test. Shopping basket 2 is the one with the solution. So we're not working with that. We are looking at shopping basket test, which has tests that are calling those functions with bugs, so we can find the bug and fix it. In your main code, you want to use shopping basket with bugs. So what I'm doing here, the instance that I'm making is an instance of shopping basket with bugs. I'm not doing shopping basket. The main code that you download is shopping basket. So make sure that you make that change here as well as here if you want to do the debugging. All right, so now I also made a test case for myself. So you go here, you make a JUnit test, you name it whatever you want, Java 11, choose the test package, and your class is shopping basket test. And then you click OK. I'm not going to click because I already have a test case for that. So my test case is called test. So now I'm going to run all of the tests and see what happens. OK, so we have 16 test cases, and 7 of them are failing. And here it tells us which test case is failing, what was expected, and what the actual result was, and so on and so forth. And on the left side, we can see all the test cases that didn't pass. So first of all, that's why test-driven development is so useful for us, because if we already have all the test cases for the program, whenever something breaks, all we need to do is to run all of our tests, and our tests tell us which part, or not necessarily which part of the code, but tells us which functionalities are failing, and we have a place to start with to look at. If we don't have test cases, we just have to do it manually, go over the code and find what the problem is. So once we have the test cases and we see which ones are failing, we want to start with the simplest test case and start solving problems from there, and step by step, test case by test case, we fix the problems. The good thing about this approach is a lot of the times we don't need to, like if we have 7 failed tests, it doesn't mean that we need to fix all of these test cases. Maybe fixing one of them can fix a lot of other ones too. So that's also why it's important to start with the simplest one, because you may end up not needing to go over the most complicated ones. You can just solve the problem with fixing a few of the simple ones. Let's have a look at the type of test cases we have. So we are testing for having no books in the shopping cart, having 1 book, having another of the same book, 2 of the same book, 3 of the same book, 2 different ones, 3 different books, and so on and so forth. So we have some test cases that by name is just suggest that it's complicated, like super complicated again, or this one that's like another super complicated one. We have some ones which are adding 5 books or 4 books, or 2 sets of 4 instead of like 5 and 3, which is like a total of 8 books. And set of 5 and 1 single, so that's 6. What we have, the simplest one is 3 different books, which is only for 3 books. So let's go to this one and try to run this. What you can do is, so you can either run the test or you can debug it. So we want to debug this test. So we're just focusing on this one test case. Okay, so as expected, it's failing, and it tells us the expected value was 21.6, but the actual value is 15.2. So let's see what this test does. It has an array of integer with values 0 to 4. And I'll explain what these numbers mean. Again, we don't need to understand all of the code to debug it. We just find where the problem is, and then we try to understand that part of the code, and we'll fix it. Okay, so let's go to the main code here.